Hello everyone, we are Group N, and our topic is called prediction. Our group member is 钟杰燕、于定生、何成元、张浩林、陈云静、林炫成 and 陈颂琪. And I'm 钟杰燕. My student ID is 109701028. And Chen Songqi, because of some personal reason, he can't attend the video recording. And here is the outline. We separated outline into 4 parts. The first part is understand and discover. The second part is simulation. And the third part is plan. The final part is organization. First, we can introduce the understand and discover. And I will talk about the definition of machine learning first. And then I will introduce machine learning process. Then we will talk about what will we do, and what do we need, and how to learn. Machine learning is a field of research devoted to understanding and building learning methods. That is, methods of using data to improve performance on some set of tasks. To implement machine learning, normally we will follow several steps. Without these steps, it may therefore be failed to complete ML. Step 1 is problem definition, and we should find the problem that we want to solve. Step 2 is data collection. We should collect the data that related to the problem, and then we should pre-processing our data. If the data has some missing data or the data that won't help us, we can remove it. And after removing the unhelped data, we can get the available data. And after getting the available data, we can construct the algorithm. And after constructing the algorithm, we can select the best model. We can put the available data into the model to test. And split the data into train and test data. Put the train data into the model and produce a prediction, and calculate the MSE value of the prediction and the true data. And after choosing the best model, we can get the optimal model. And after obtaining the optimal model, we can implement performance evaluation. And based on the performance, we can adjust our parameter. And after the parameter adjustment, we finally get an ideal model, and we can apply the ideal model to predict the things that we need.
Hello everyone, I am 109701037 Yu Dingsheng, and we've got the steps of machine learning. And then we are going to follow those steps to complete our machine learning project. The first problem is what will we do? Let's talk about something that we are confused first. Well, we had wondered if we find several parts of a song or music, but we don't know its sequence. Can we reassemble the whole music? And why are some songs sound so good when put together while others not? Are there any regularities? If those regularities do exist, can we find and use them to predict or generate music? Can we make music that satisfies some characteristic we want by computer? So, with the question above, we wonder if we can solve it by machine learning. We think that the foundation of music is chords. There must be some secrets in chords. So, if we can find the regularities of chords in different music, then we might be able to use the algorithm to predict the next chord of the music. Moreover, maybe we can create our own music. Therefore, we want to make a predictor that helps us predict chords. And this is what we will do. It's about the steps of problem definition. So we've known what we are going to do, and the next question is, what do we need? We have to know what we need and then collect them. For the purpose of analyzing music, the most important data is MIDI files of music or songs. No matter what type of music, it's fast or slow, it's classical or modern, all of them are what to collect. The more data we get, the higher probability that we may successfully predict. After getting data, the next step is to filter this data. The object being predicted is the course, so we only need to leave the course. The remaining can be removed, such as the type of instruments or melody, then can all be removed. And it's about the steps of data collection and pre-processing. The data is okay. What's waiting for us is a final challenge: how to let machine learn. The first thing is to have the computers read the data, of course. And then we have to write algorithms to train computers. To write algorithms, we have to choose the most suitable model. And after training computers, machines can learn some characteristics about our data. They can identify whether there are regularities in different sets of codes and conclude the relevance of them. And it's about the steps of available data to algorithm construction to model selection. Then, after obtaining the most suitable model, when we input a specific condition to machines, they can calculate the probabilities of the different consequences and finally return the most likely result of the next code. In this step, we've successfully predicted the code. However, it's not finished yet. We have to test its accuracy. If it's not so accurate as we thought, we should fix it. By testing and fixing for many times, we can get the ideal model of machine learning. So now we can eventually predict the course. And it's the steps of optimal model to performance evaluation to parameter adjustment to application. We have known how to follow the steps and complete our machine learning project. So, are you ready? Let's go!
Hello everyone, my name is He Changyuan, and today I'm going to talk about the model that we choose to complete our goal. To select the most suitable model, let's see what our input and output look like, and so that we can select the most suitable model easily. And first, I'm going to talk about the input and output. We want to generate music based on several chords that the user gave us, and these chords will be used as the beginning of our song. Therefore, our input will be the chords that the user gave us, and we will predict the next chord as the output. Thus, we can say that our output is the nth chord, and we can use the first chord to the n-1 chord as the input. And next, I'm going to talk about the model we select. And we want to choose the model that can generate or predict the nth chord with all information, not only a part of them. Therefore, the fully connected neural network doesn't work because that the input size is fixed for the fully connected neural network. So what we choose is the recurrent neural network. We can call it the RNN. And RNN is a neural network that works with different amounts of sequential data. The biggest difference between RNN and the fully connected network is that the RNN have feedback loop. This is the feedback loop. And although the recurrent neural network may look like it only takes a simple input value, the feedback loop make it possible to use the sequential input values to make prediction. And then I will briefly introduce how RNN work. Okay, first we look at this line. This is the first step. And if the first input is the first chord that the user gave us, and we can predict the second chord here by the weight and bias. And when we want to predict the third chord, we not only use the second chord as the input. Follow this connection. This is the feedback loop. We use the result of the first activation function as input too, and sum them, and we can predict the third chord by these two information. And then when we want to make prediction of the nth chord, we just keep unloading the RNN until we have an input for the nth chord. That is the activation function value of the n-1 chord. And then we can predict the nth chord. And this is how RNN works.
Hello everyone, my name is Zhang Haolin, and another classmate He Chunyuan and I are in charge of the simulated part. This time I will explain how we interact with the users. First of all, the user should prepare a few chords at the beginning, and the program will generate the following chords according to this chord music. And next, you should decide your instrument type. And there may be options such as guitar and piano, and then you should determine how many chords that should be generated, and the total time of the whole song is whole music. And next is the steps to use the program. First, you should import your MIDI file, which is the first few chords, into our program. And then next, you should enter your instrument type, total time for the whole music, and the chords amount which will be generated. And third, you can select a specific output location if desired, but it's not necessary. And last, just wait for a moment and the entire complete music will be output.
Hello, I'm Lin Xuanchen. I'm here to introduce our plan. That is, how to use the Python code to realize our project. Our first step is to load the file into our program as the machine learning code. And then we will use some code to dictate the file name and save all the .mid file into a list to save the file name, and then return it as an old MIDI list, and then use the extract nodes to read the file name with in old MIDI and take the nodes return as a corpus list. And then, as I said, we would want to pre-processing before we build a model, and then we will create a list of source unique chords. We do it by turn the list into a set and then return to a list and then sort it. The set will only save a not unique element that is to use, and then we save mapping as a dictionary of thing, and that will have a reverse one because we will want to use the I as a searching element and or C as a searching element, and then we can encode in and splitting a corpus that will have a length with the splitting, and that would be decided by our numbers of the MIDI file in the database. And then we created two lists, features and targets. That's to split the trend and seed data set. X will be reshaped with the features, and the Y will be shaped with the targets. The two will use the trend and theta split to build the X trend, X seed, Y trend, and Y seed. These two, one of it to split with the two list, and then we can do the building model step.
Okay, after we have our data signified, we are going to building model. We find an API named Keras might help us to accomplish our project. First, we need to initialize the model. We can import sequential function to help us. Then, we need to defining the model by adding layers. We can find layers by import LSTM, dance, or drop-off function. And since the first layer is to define what kind of input the model can receive, we need to choose the layer carefully. After that, we are going to compile the model. Layers are a function just named compile to help us. This part is to define the way we will going to train the model. Next, we can use the data we had sorted out to starting training the model. We found that the function fig might help us in this part. Finally, we need to define a function to finish our project. In this function, we hope that it can achieve when we give the function some chord as sample. It can come up with a music that is composed of the chords similar to the sample chords we give. Moreover, if we have enough time, we can try to let the function can control how long or how many chords we want in our music, or what kind of instrument we want to also add into function input, just like the picture. And we can even try to make our function can choose what type or reset what kind of mood we want for our music. After we finish our plan, we found many obstacles that might show up when we really start to accomplish our project. One of the obstacles is database problem. Database problem might include where we can get the MID file we need, how many films we can find, and how many types of MID film included in our database. The film, we think we can find it online, but we worry about that we can't find enough film to train the model. Even though we collect data successfully, we still need to worry about how many types are there in the data. There are different sizes of chords, different type of mood in different music, and different instruments. If the MIT field we collect has too many different kinds of music, how to classify it and how to use it to train a model are the big obstacle to us. How to write Python code is also a big problem. We only learn about machine learning in theory but haven't tried it before. We have no confidence about writing the Python code, so we have found some samples online and done a plan report according to it. But our project is not exactly the same as the sample online. And the sample online also had some shortcomings, like the music it makes is too monotonous. We guess this problem can caused by the code it gave to train model is too little. We're really worried about that. We don't know what to do when our code is wrong and how to adjust the code if it can achieve our goal. But it was a shot, right? We believe we will overcome all these challenges together. And we also believe that our smart and nice professor and teaching assistant Edward will help us when the project is going to make us crazy.
Here's our organization, and I'm the leader, and me and Yu Shen are responsible for understand and discover. He Chengyuan and Jiang Haoling are responsible for stimulate. Chen Yunjing and Lin Xuancheng are responsible for plan. And Chen Songqi was responsible for organization and presentation, but he can't attend the video recording because of some personal reason. So Jiang Haoling is responsible for presentation instead. And that's all of our presentation. Thank you for listening.